Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over two examples on how to multiply and divide rational expressions. The instructions are as follows. For each given function, we are to first find the constraints on the domain of the rational expression, and then the second task is to simplify the expression. Now, the strategy we're going to be using to carry out these steps is enumerated for us in this box to the right. So first thing you want to do when you're multiplying or dividing rational expressions, first of all, you want to multiply the dividend by the reciprocal of the denominator if you were dividing. Okay, that procedure is commonly known as drop, change, flip. You drop the dividend, change the division to a times, and then you reciprocate your divisor. Okay, after that, or if you have a multiplication, you jump straight to step 2, which is you factor if you have a polynomial expression that's not prime, or you decompose if you have a monomial that's composite. All right, after that, you reduce by dividing out common factors from the numerator and denominator, and then you finish it off by multiplying. Okay, all right, so let's take a look at problem number 1. The first task is to find the constraints. So constraints are the values of the variable that will result in an undefined output for the expression. So what causes irrational to have an undefined output? It is when the denominator attains a value of 0. So what we're going to do here is set both denominators to 0 since they have a variable term associated with them. So 7p cannot be 0, and 9p cannot be 0 also. Okay, let's go ahead and solve this. The first one, you divide both sides by 7, and you end up with p cannot be 0 over 7, which is 0. P cannot be 0. The inequality on the right can be solved by dividing both sides by 9, and you have p cannot be 0 over 9, 0 also. Okay, so you basically have the same constraint for both terms that we're multiplying here. So that's the constraint on this polynomial expression. Now let's go ahead and simplify, which is the second task that we're to execute. So let's simplify. And the title is Simplification. Now we're going to be using the steps outlined in our strategy list to carry out this process. Okay, so let's rewrite the problem. We have 6 over 7p times 10p to the 4th divided by 9p. Step number 1, if you're dividing, you drop, change, flip, or multiply the dividend by the reciprocal of the divisor. We do not have a division here. This is a multiplication problem, so we're going to advance straight to step 2, which is factor or decompose. So we're going to be decomposing composite numbers or polynomial terms here, since we do not have polynomial expressions that are factorable. Okay, so 6 can be decomposed using your factor tree into 2 times 3, and then 7p is 7 times p, times 10 can be decomposed into 2 times 5, and then we're going to have p to the 4th can be decomposed into p times p times p times p. You have 4 copies of p. That is what p to the 4th is in decomposed form. 9 can be decomposed into 3 times 3 times p. Okay? All right, so now we've decomposed. Next thing we're going to do is we're going to reduce by dividing out common factors from the numerator and denominator. Okay, so remember when you're dividing out, you can only divide downwards or across. You can divide horizontally, left, right. Okay? So let's see what I can divide out here. P goes here 1, P goes here 1. See how I divided 1 in the denominator, and then 1 in the numerator. Okay, you cannot do denominator with denominator or numerator with numerator. All right, 3 goes here 1, 3 goes here 1. That's another one. It can be factored out. Let's see what else. We can divide out P. P goes here 1. P goes here 1 also. Nothing else can be factored. There isn't any 7 upstairs, no 3 upstairs, okay? No 2 or 5 downstairs, so that's the reduced form. We're done dividing out common factors. Lastly, we'll just simply multiply. Our final result will be 2 times 2 times 5, which is 20. We have 2 p's there. P times p is p squared. Let's write that again. 20 p squared divided by 7 times 3, which is 21. Okay, so this is the simplified form where, let's state the constraint, where p cannot attain the value of 0, or else you will have an undefined output for the original function. Okay, so that's the final answer for question number 1. All right, let's take a look at problem number 2. We are to find the constraints on this polynomial expression right here, this problem, and then we're to simplify completely. Okay, all right, so let's go ahead and start out by finding out the constraints. Now when you're looking for the constraints, you're basically looking for values of r where the denominator cannot attain a value of 0. Okay, now to do that, we want to take a look at the denominators. R minus 7 is the denominator of this term right here, but we're dividing by this rational expression. So what is the real denominator here? In order to determine what the real denominator is, we're going to have to drop, change, flip, or multiply this dividend by the reciprocal of the divisor. So we're going to drop this entire rational expression, 7r squared minus 49 divided by r minus 7. We're going to change our division to a times. We're going to multiply this by the reciprocal of the divisor. Denominator goes to the top, and numerator goes to the bottom. Now, what are our two denominator polynomial expressions? We can clearly see that they are r minus 7 and r squared minus 4r plus 3. Okay, so let's go ahead and find the constraints. Remember, this is when the denominator cannot be equal to 0. Let's extract the first denominator. We have r minus 7. That can never be 0. To isolate r, we'll simply add 7 to both sides of our equation, resulting in r not being equal to 7. Okay? If r attains a value of 7, this polynomial expression will be undefined. Okay? So that's why we have to place that constraint on the possible values of r. Now we're going to extract the second denominator, r squared minus 4r plus 3. This polynomial cannot be 0. Now we have a quadratic inequality here, so we can go ahead and use the x game. Let's hope that this expression is factorable. We have 3 as AC, negative 4 as B, using the AC method of factorization. Now what two numbers multiply to give you 3 and add to give you negative 4? Negative 1 and negative 3 fits this description. So this polynomial expression now becomes r minus 1 times r minus 3 cannot be 0. Remember here, a is 1, so we do not need to factor by grouping. If a were not 1, then we have to factor by grouping, okay? Now we're going to set both factors not equal to 0 and solve. The first one, you simply add 1 to both sides. So that tells you that r cannot be equal to 1. On the second equation, you simply add 3 to both sides. And that tells you that r cannot be equal to positive 3 also. So these three values, 1, 3, and 7, are constraints on the domain of this function, the original problem. If the original function that we have up here attains any of these values, our result will be undefined. So we have to exclude those values from the domain of our problem. Okay, now let's advance to the second part of the problem, which is the simplification piece. So let's refer back to our steps here. When you're dividing, of course, you multiply the dividend by the reciprocal of the divisor. So you drop, change, flip. We have already executed that step here. So we can copy it. So you have 7r squared minus 49 divided by r minus 7 times r squared minus 9r plus 8 divided by r squared minus 4r plus 3. Okay, so we are done with the first two steps. Actually, we just finished the first step, which is drop, change, flip. Now we're going to factor each term. 7r squared minus 49 has a GCF of 7, so we can factor out a 7 from here. So we have 7 times r squared minus 7. Okay, now that divided by r minus 7. Now let's take a look at this piece right here. R squared minus 9r plus 8. We can easily factor that using the x game. AC in this case is positive 8, and B is negative 9. What two numbers multiply to give you positive 8 and add to give you negative 9? Negative 1 and negative 8. So the numerator to the right is r minus 1 times r minus 8. Now if you direct your attention to the denominator on the right, that polynomial expression has already been factored. It was factored here when we were looking for the constraints, because this polynomial is a denominator polynomial. Okay, so its factored state is simply r minus 1 times r minus 3. Just copying what we have here. We don't have to do all the work again. Okay, so now we have the factored form. Now let's go ahead and start crossing out common factors. So we have r minus 1 goes there once, and r minus 1 goes there once. And that's basically it. No other common factors to factor out. So we have our final answer, 7 times r squared minus 7 times r minus 8. That entire product divided by r minus 7. We're multiplying here, so denominators go with denominator. Okay, and don't forget the constraint where x cannot be. Let's look at our three answers here: 1, 3, or 7. In order for our original function to be defined, we have to consider these constraints. Okay, so there goes your final result for problem number 2. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial beneficial to you, please give us a thumbs up. We appreciate the positive feedback. Do not forget to subscribe to our channel for updates to other math tutorials such as this. If you have any questions about this clip or any problems related to rational expressions, just place your question in the comment section below and we will address your question as soon as possible. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.